When you picture a gravel road, what pops into your head? Probably a dusty, bumpy track, right? Something way less sophisticated than a paved highway. Well, what if I told you that was completely wrong? Because an unsealed road isn't some forgotten path. It's an incredibly smart piece of engineering with a totally unique design philosophy.
And you might be surprised just how important they are. I mean, get this. In huge parts of the world, especially in rural areas or places with lots of mining and farming, these unsealed roads make up more than 60% of the entire road network. They are the absolute lifelines that connect communities and fuel economies, where a big, expensive highway just makes no sense.
So, first things first, we gotta completely ditch the idea that a gravel road is just a highway that's failed or hasn't been finished yet. Nope. It's built on a fundamentally different principle, designed from the get-go for a completely different job.
Okay, so here's the core difference in thinking. A sealed road, with asphalt or concrete, is designed to be a fortress. It's an impermeable shield trying to keep everything out, aiming for a super long life with as little work as possible. But an unsealed road, it's designed to live with nature, not fight it. It totally accepts that, yeah, water's gonna get in, the surface is gonna wear away. And because of that, it's designed to need regular, planned maintenance, like grading, to keep it in good shape. It's all about managed wear, not permanent resistance.
So how do you actually engineer one of these? Well, it's a lot more than just dumping some gravel on the ground. Designing a good unsealed road is a really careful balancing act. You have to consider the traffic, the materials you can find locally, and the climate. Let's dive into how it's actually done.
Right, so engineers aren't just winging it. They follow clear, systematic processes, like the one from Austroads. There's a whole procedure. First, you figure out the traffic load. Then you test the local dirt and rock to see what you're working with. You classify the road. Is it a busy U1 or just a basic U5 farm track? You measure how strong the ground itself is, and only then do you figure out the exact thickness of each layer of gravel. It's a precise, step-by-step science.
Okay, so you see this term on the list, ESA, or Equivalent Standard Axles. What on earth is that? Well, it's basically how engineers measure wear and tear. A huge mining truck obviously puts way more stress on a road than a small car does. ESAs are just a standard unit that lets them add up all that stress over the entire life of the road to get one single number. It's how they predict the future.
And the next big piece of the puzzle is the CBR, the California Bearing Ratio. All this is really is a test that answers a super simple question. How strong is the ground we're about to build on? A high CBR means the ground is solid, so you might need less gravel. But a low CBR, that means you've got soft, weak ground, and you're going to need a much thicker, stronger road on top to spread out the load.
So let's actually build our road, starting from the ground up. Everything, and I mean everything, begins with the subgrade. That's just the natural ground itself. Its strength, that CBR value we just talked about, dictates the whole design. If this foundation is weak, say it's some soft, squishy clay, the whole road is at risk before a single car ever drives on it.
All right, on top of that properly prepared ground, we lay down the base course. This is the real structural powerhouse of the road. It's a thick, compacted layer of really good quality crushed rock, and its main job is to spread the load. It's kind of like wearing snowshoes. It takes all the pressure from a tire and spreads it out over a huge area, so the weaker ground underneath doesn't just collapse.
And then, right on top, you have the wearing course. This is the part you actually drive on, and man, it has a tough life. It has to resist getting ground down by tires, it needs to hold together to keep dust down, and most importantly, it has to shed water like a duck's back. Think of it as the road's sacrificial skin. It's designed to take a beating day in and day out, so the important structural layers underneath stay safe.
And that brings us to the single biggest threat to an unsealed road's survival. It's not the heavy trucks, it's not the sun, it's water. Because that surface isn't waterproof, managing moisture becomes the #1 priority.
So, if you had to name the unsealed road's greatest enemy, what would it be? It's water. For sure. It's the rain that soaks in from the top, turning those strong gravel layers into mush and transforming that solid foundation into soft, useless mud.
So what's the road's main line of defense? This number right here. An unsealed road is built with a really steep crown, or crossfall, somewhere between 4 and 6%. Now, to put that in perspective, that is literally double the slope of a normal highway. It's why you can sometimes feel your car leaning to one side. And that aggressive angle exists for one reason, and one reason only: to get rainwater off the surface and into the ditches as fast as humanly possible before it has a chance to soak in and cause chaos. Okay, so if the road is constantly under attack from water and traffic, how does it last? Well, this goes right back to that philosophy we talked about at the start, a life of managed wear. The road is fully expected to break down, and its repair schedule is planned from day one.
In fact, losing gravel isn't even considered a failure. It's an expected part of its performance. Civil engineers know that traffic and rain are going to slowly strip away that top layer. They actually calculate how fast it will disappear and build the road extra thick from the start just to account for this inevitable loss.
Of course, this planned decay has consequences. For you, the driver, it means the road gets rougher and dustier. For the council or company that owns the road, it means their asset is literally getting thinner. And for the environment, it means dust flying everywhere. And that is exactly why managing this process is so important.
And this is how they do it. It's called the maintenance cycle. A grader comes through regularly to smooth out the corrugations and, most importantly, to reestablish that steep 4 to 6% crown. But the final move, the big one, is resheeting. That's when they bring in truckloads of new gravel, usually every 8 to 12 years, to replace everything that's been lost. It's a planned, circular process that literally brings the road back to life, again and again.
So, what's next for the humble gravel road? Well, the core engineering principles are still the same, but new technology and a big push for sustainability are making these roads smarter and more efficient than ever before.
I mean, today we're seeing graders guided by GPS that can reshape a road with millimeter accuracy. There are incredible new chemical agents that can bind the surface together to fight dust. Engineers are getting really creative with recycled materials, like crushed concrete, and are even using special fabrics, called geosynthetics, to add strength when they're building on weak, swampy ground. This whole field is always moving forward.
So the next time you turn off the smooth asphalt and hit the gravel, take a second. Are you just seeing a dusty track? Or are you seeing a complex, living structure meticulously designed for a life of managed wear? A calculated balance of engineering, geology, and water, all working in harmony with the environment. It's a whole lot more than just a dirt road.